Hey everybody, welcome back. So today we're talking about what our lesson 5 is about. This is heat transfer. So to understand heat transfer, you have to understand what temperature is and what thermal energy is. So temperature is the thing we measure with a thermometer, right? Temperature is the average speed of particles. How could we possibly show this? What you'll notice in this video is that the average speed of the teachers, the particles, is really fast, so their temperature is high. We are hot in temperature because we're moving fast. Fast particle speed, hot or high temperature. So what you'll notice in this video of these 3 wonderful teachers is that even though their speeds may be a little different on average, they're moving kind of in the middle, kind of a medium speed. Medium speed means medium temperature. Medium speed, medium temperature. When the average particle speed is really slow, it's a low speed, you get a low temperature. Even though, if you notice, all of them aren't slow, just on average they're slow. So slow speed, low temperature. Low speed, low temperature. What a raucous group. So thermal energy is a little bit different. Thermal energy isn't just the average, it's actually the total. So if I have a tiny little hot thing, its average temperature is really high, but its total energy, because it's tiny, isn't that big. But if I have a really big cold thing, even though its average temperature is really low, its total energy might be actually pretty high because there's so much of it. So I wonder how we could illustrate that with teachers in a hallway. When I transfer my thermal energy to the whole group, we all move at about the same slow speed, even though I was moving a lot faster before. The thermal energy was the same before and after the collision. But when I was the only one with all that thermal energy, my temperature was high. But when the whole group had that thermal energy, the temperature was low. I would consider replaying that last bit, because it can certainly be a little confusing. Don't be shy about pausing, rewinding, and playing it as many times as you need.
This just in. There are 3 types of heat transfer: convection, conduction, and radiation. We go to Mr. Bowtie on the scene for further explanation.
Oh, Mr. Boytett on the scene. So, we have right here in our very midst a demonstration of convection. Heat from the hot plate travels through the liquid and transfers through a moving liquid. Convection. We also have in our midst, right here, a trip down memory lane of more convection. Liquidy mantle convects heat from the hot core up towards the surface, causing plate tectonics. Convection. To measure convection, we simply put a thermometer in the part of the liquid that's not directly touching the hot plate, the top. And we see the energy that was transferred from the bottom to the top through the moving liquid. And it is going up quickly. We are up to 90, 95, all the way up from between 20 and 30 where we started. But, where's the radiation and conduction? Wait a minute. We have radiation right here. The warmth touching my hands, radiating from the hot plate, is radiation. To measure heat transfer through radiation, we simply hold the thermometer not touching the hot plate to see how much energy transfers through air. We're up to 60, 61. Which one? If I were to touch this hot plate, ow! I'm not going to do it. If I were to touch this hot plate, conduction, direct contact, touch, transfers heat. To measure conduction, we simply touch it to the hot plate, the source of energy. Conduction. Now we are starting at 55 and we go down to, we're up to 60, 65, 70, and we'll keep rising. Conduction. Which one do you think is the fastest? Conduction, convection, or radiation? Which one transfers heat the fastest?